Hello everyone, welcome to Bright Engineering. Today we are going to look at differentiation, and then under differentiation we are going to look at something we call the product rule. Now, most often than not, when we are differentiating functions, we have single functions and then we differentiate. What if we have two different functions that have been multiplied to give us a single function? In this case, we have x squared and here we have 3x plus 5. There are two different functions that we have to differentiate, right? So if in order to differentiate these two functions or this product of a function, then it means that we have to apply something that we call the product rule. So f prime of x, which stands for the differentiation of this function, we are going to use something. We have v du dx plus u dv dx. Right, so don't worry, we'll go into this very soon. So now these functions, as we've already established that it's a product of two different functions, are going to take the form of v and then u respectively, right? So here we are going to make this stand there as u and then this stand there as v. So we are assigning variables to it, right? So let's say our u is x squared and then our v is 3x plus 5, right? Now, looking at this equation or this formula, we know we have du dx here. It means that we've differentiated the u function with respect to x. So it means here we have to differentiate this. So in differentiating this, we are getting du over dx, and it's going to give us the power multiplying the whole expression, and then we will subtract 1 from the power, right? So we are getting 2x like that, because we get 2 minus 1, which is going to give us x raised to the power 1, and it can be written in this form. And here, differentiating v, we have dv dx, and it is going to give us 3, right? Because when you differentiate 3x, you're going to get just 3, and because 5 is a constant, when you differentiate 5, you're going to get 0. So this is what we have, right? So now our f prime of x is v, and here is our v, so we have 3x plus 5 times du dx, and our du dx is 2x, right, plus u, which is x squared, times dv dx, which is 3, right? So yeah, so now our answer becomes 2x into bracket 3x plus 5 plus 3x squared, right? But then alternatively, we are going to go about this same way, and then we are going to derive this same answer. But then most at times students find it difficult to keep this particular formula in their head, so whenever it gets to finding the differentiation of a product function, they get confused, right? So now we are going to look at how you can also find this without keeping this formula in your mind, but then you are going to derive at the same answer, right? So we have f of x equal to x squared 3x plus 5, right? So this one we go by this, by you keep this, you differentiate this, plus you keep this, you differentiate this, as simple as that, right? So here differentiating this, you get f prime of x is equal to, you keep this, differentiate this. So now we are going to keep the first function, which is the x squared, and now we differentiate the second function, which is the whole of this, or what is inside this box, right? And when that differentiating 3x plus 5 is going to give us 3, because this one will give us 3, this one will go to 0, right? So now we have 3 plus, we differentiate this, then we keep this. So because we kept x squared for the first function, now with the second one we're going to keep the second function, which is our 3x plus 5, right? So now we've kept this, and now we are supposed to differentiate the other, which is the x squared, and differentiating this, the 2 will multiply the x, and we subtract 1 from the power. So here we get 2x like we did, right? So you can just leave this like that, because that's the same as what we had here, or you can rewrite it if you want to get 3x squared plus 2x into bracket 3x plus 5, right? Which is the same answer we have here. You can also decide to exchange it or leave this like that. You can decide to exchange this or leave this like that, right? Thank you very much for following us through this video. If it's been helpful, please don't forget to comment, like, subscribe, and then share.